math stars. Our brilliant is just going to move right along with comparing more fractions. And as you can see, today we'll be definitely comparing using a lot of greater than, less than, or equal signs. And in addition, great thing about today is we'll learn how to compare with both common numerators and common denominators. So meaning we'll learn how to compare when the numerator or the number on top is the same, and also to compare when the number on the bottom or the denominator is the same. So let's get to it. So your first section asks, compare the pairs of fraction by reasoning about the size of the units. Okay, seems easy enough. I'm actually will do 1B with you right now. And I've decided to do this because, or I should say I have decided to use a tape diagram to help me through these problems. So I'm going to compare 3/4 and 3/5. And just for the sake of being logical, I'm going to rewrite this in fraction form. So in fraction form, 3/4 is simply just 3/4. 3/5, that's simply 3/5. And we have to think, would 3/4 be bigger or would 3/5 be bigger? Okay, I'm going to draw my tape diagram and call it a chocolate bar to reason through this. Okay, I'm going to start with the 3/4 and I'm going to shade this accordingly. So if my fraction is 3/4, I would have 4 equal pieces. 1, 2, 3, 4. And I'm going to eat 3 pieces or shade in 3 pieces because my numerator is 3. And now for 3/5, I'm going to be conscious and draw the same size chocolate bar, same size tape diagram. But instead of 4 equal pieces, I am going to have 5 equal pieces. So let's draw this into 1, 2, 3, 4, 5 equal pieces. Okay, and let's do it. 1, 2, and 3. Ooh, it looks like if I am going to eat 3/4 of this chocolate bar, that is more pieces, or that is a bigger quantity than if I would eat 3/5 of it. So then I'm going to go ahead and showcase that 3/4 is actually greater than 3/5. And an easy trick to this is that usually when the denominator is smaller and the numerator is the same, so numerator is the same or equivalent and denominator is smaller, that number is equal. Because that number is greater. Because as we just saw in our tape diagram, we end up eating more, or we'd get a larger portion of the tape diagram or the chocolate bar if we're allocated 3/4 of it rather than 3/5. Okay. So I want you guys to try A, C, and D on your own. 2 asks us to compare by reasoning about the following pairs of fractions with the same or related numerator. So once again, our number on top, our numerator, is going to be the same. Using greater than, less than, or equal. And then I want you guys to continue to use pictures, specifically tape diagrams, area models, chocolate bars, whatever you want to call them, for these problems, just to showcase what you're thinking. Okay. Problem 2B has been done, so they did 2B for you. So 2A should be pretty simple because we already did it for question 1. And I want you guys to try C. I'm going to go ahead and do D right now. And D is a little bit more tricky because we first have to convert the 6/7 in order for 12 to be the numerator. And so we have equal numerators. So how can I get 6 to equal 12? Well, isn't 6 times 2 equal to 12? Yes. So as we learned about last week and in previous units, if we multiply the numerator by a number, we must multiply the denominator by that same number. So 6 times 2 is 12. 7 times 2 is 14. And then I know that 12 over 14 is the same thing as 6 over 7. Now I'm going to compare 12 over 14 and 12 over 15. Awesome, fantastic, my numerator is the same. And if you remember the trick that I just mentioned, okay, numerator is the same, and 14 is a smaller number than 15. So I'm going to say that 12/14 is greater than 12 over 15. Okay. So that might be a little confusing because you might think, oh, 15 is bigger than 14. And yes, that's the case. But we're dealing with fractions right now. And when we're dealing with fractions, if there's a bigger number on bottom, if the denominator is a bigger number, that number actually ends up being smaller. Okay? So 12/14 is greater than 12 over 15. And I could also showcase that just for the sake of time. And since you guys already understand it, I'm not going to showcase it using a tape diagram, but please feel free to do that for 2D when you're doing these problems. Okay, 3. Draw 2 tape diagrams to model each pair of the following fractions with related denominators. Okay, so now we're moving into related denominators or equal denominators. And pretty simple stuff, okay? Especially because they've been kind to us early on, and these denominators are multiples of each other, okay? So we don't have to do any funky multiplication. So for my first problem, I have 2/3, and then I also have 5/6 or 5 over 6. Okay, and I'm gonna try 6 is my bigger denominator. So I'm going to try to get this 6 or this 3 equal to 6. And how would I do that? Well, 3 times 2 is equal to 6. Okay, so that means I need to multiply my numerator and denominator by 2. So 2 times 2 is 4. 3 times 2 is 6. So I know that 2/3 is the same thing as or is equivalent to 4 over 6. And I'm comparing that to 5 over 6. And this is super easy stuff, right? Because, the denominator is exactly the same, and just my numerator is different. And we know that 5 is a bigger number than 4. So I would simply draw a greater than sign to the 5. I could also just showcase this right now on my tape diagram or my chocolate bar. So originally, this is also kind of a review from last week. I would have 2/3. I would shade in 2 pieces. And then if I wanted to have 4 pieces, super easy, I would just, or I'm sorry, if I would have 6 pieces, I would divide each piece then. So now this showcases 4 over 6. And then my 5 over 6 would simply look like 1, 2, 3, 4, 5, 6. This. So as you can see, more shaded in for my 5 over 6 than my 4 over 6. Okay, I want you guys to try B and C on your own. And a hint for C, you see this 1, so both are equal to 1, or both have 1 in their fraction. So since they do that, you can just simply ignore it for the sake of comparing, okay? Because they both have 1, okay? I hope this is slowly making sense, more and more sense. Math stars, you guys are doing awesome, and have a great rest of your day.